a wonderful audience. And I feel like it's a great opportunity to talk with you and share some of the science about the chemicals in the products that you use or make or buy or design, and how you can make the things healthier and safer. And when I started doing this work, I used to talk about policy changes for healthy chemicals, healthy products. And in terms of flame retardants, policy is really important. But now I've decided purchasing is what it's all about. And I hear there are lots of people here, in fact, we all do purchasing as consumers and in our jobs. And I really come to believe that purchasing is the magic. And so we're going to learn a little bit more about that. But let me just ask, how many of you think if a chemical is in your toothpaste or your shampoo, someone in the government is making sure it's safe for your health? Minority. Okay, well, unfortunately, that should be true. We wish it were. But unfortunately, it isn't. And the reason, the problem is there's only one law in the United States about chemicals before they go out in the world. Once they're out there, there's a Clean Water Act, a Clean Air Act, but once they're out there, it's hard to bring them back in. And that is called the U.S. Toxic Substances Control Act. It was passed in 1976, and 62,000 chemicals were grandfathered. Like, they're fine. An example is asbestos. 10,000 people a year die of asbestos disease, and the EPA tried to regulate it for several years and could not. Is that surprising? And you're probably saying, wait, asbestos, we get the asbestos removed from our houses, it's really expensive, there are asbestos lawsuits. And what the story is there's a rare form of cancer called mesothelioma that's only caused by asbestos. So if you're an asbestos worker or the wife of an asbestos worker and you get mesothelioma, you will sue and you'll win, but you'll die. Everybody who gets mesothelioma dies. And that's how we are able to regulate asbestos. That's not the best way. But the EPA, our government, is powerless because it's one of the grandfathered 62,000 chemicals. Now, there have been 20,000 new chemicals since TSCA, but there's no requirement for any data at all. 2/3 of them have zero data, and the government is supposed to regulate them with no data. It doesn't happen. So we really, now, wait, you talk about government regulation. Foods, drugs, and pesticides, things that go into our mouths, are regulated. And you might argue, is it well enough regulated? But a food, a drug, or a pesticide really does have to be evaluated and regulated. But all the other chemicals that can be in our cosmetics, our shampoo, our furniture, there really is very little effective oversight. And this has led to two very brilliant pediatricians saying, we are conducting a massive clinical toxicological trial, and our children and our children's children are the experimental subjects. So all these unknown chemicals with no data go out into the world, and we are exposed. We are the experimental subjects. Another problem is when a chemical is regulated, industry tends to want to keep things as similar as possible, so they tend to substitute a chemical cousin with very similar properties. So there's a flame retardant, just a little chemistry. It's called DECA, which means 10, bromo, 10 bromines, diphenyl, this is a phenyl ring, 2 phenols, ether, this is an ether bond, Brominated, diphenyl, ether. And this chemical that was used, maybe it was 15% of the weight of the plastic around our televisions. It was found out to be persistent, that means it stays around, bioaccumulative, and toxic. And it has been phased out, which is a very good thing. But the replacement is DECA-bromo diphenyl ethane, virtually identical in structure, also persistent, bioaccumulative, and toxic. So the sales of the DECA ether go down, the sales of the DECA ethane go up. Is that an improvement? That's the chemical cousin problem. And this is what we've seen with many chemicals. So hard to phase out a regulated chemical. Usually a state does it first, and then the chemical cousin appears. So those of us who really care about these issues looked at this problem and thought, what can we do? And we decided to bring together a group of people who are scientists from academia, from industry, from government, and from the nonprofit sector, and really spend several days, have a retreat, think about what can we do to really reduce exposure to these harmful chemicals in our products that end up in our population and end up in the environment. And we came up with a solution. That's what I'm going to talk about. Everybody's looking worried, and I'm looking happy. There will be a solution. And I'll tell you right now, and then we're going to understand it. And the solution is, when you hear 80,000 industrial chemicals with little data, you just kind of think, what can I do, right? Overwhelming. But the solution is most of the really harmful chemicals are in 6 classes. And we can learn to understand what's in those 6 classes and remove them from our products. So it's not like thousands of CAS numbers, you don't have to be a chemist. And so just today, I'm going to teach you about half of the classes. That's all the time we'll have. Tell you how you can learn about all of them. And once you understand, you can make educated choices yourself. And I'll just say what they are now, and then we'll go through them in more detail. So they're highly fluorinated chemicals like Scotchgard, stain, and water repellents. How many people here knew before that Scotchgard and stain and water repellents are problematic? Did anybody know that? Okay, a bunch of you did. And indeed, well, I'll just say right now, when I was looking at today's news, there's a trial today about those chemicals being leaked in the water supplies in communities in southern Ohio, near a DuPont plant, and that happened a long time ago. But it's an interesting story. I'll wait till we come to those. Okay, we'll go through. All right, but it is all happening today on the stain repellent, so like right today. Kind of interesting. Then there's chlorinated antimicrobials, like triclosan and triclocarban. How many people know that those are problematic? You? Flame retardants. I bet people here have heard that. How many people know flame retardants are problematic? Okay, we know about those. Bisphenols and phthalates. People, right, we all want those water bottles. Organic solvents like methylene chloride, it's good roots, yeah. And then, of course, we know about lead, right? And mercury, and cadmium. Okay, so you look at this list. That is a big chunk of the harmful chemicals in our products. Not all of them, but it's 60, 70, 90%, somewhere in there. And we can learn what they are, and we're saying we can reduce their use by about 50%. And the whole world will be healthier. And how do we do that? We do that by asking, is it necessary? That's the big question. When your chemical is harmful, in one of those classes, you say, do I really need it? So if you say to a mom, you can have a perfectly stain-repellent carpet, but there's going to be a fluorinated chemical. That chemical will end up in your children when they crawl on the carpet, and it's a chemical that won't break down for geologic time. That's for millions of years. It's going to stay on the planet forever. It's going to stay in your baby's body for a long time. Is that mom going to want that stain-repellent carpet? She'll say, is it necessary? Or certainly, is it worth it? But just say someone else says, well, the carpet's white. I really can't have stains on my carpet, I think it's necessary. I think it's worth it. Then is there a safer alternative? Can I have that function without that sort of chemical? And that might cost me more money, but I think it's worth it because I know it's harmful, but I want it. But that first question, I think just asking, is it necessary? We could go to 50% on the worst chemicals in everyday products. And if you think of how much healthier all of us, and if any of you like me worry about the bees and the bats who are really having a hard time, they have all these chemicals in their bodies and it's not helping their health, just like it's not helping ours. So I think the is it necessary question is a really important one. Once you understand where the harm is, I always say, well, if you're climbing Mount Everest, maybe you really need that ultimate waterproof jacket. But we actually climb Mount Everest without those, but that's another story. But do you need that degree of water repellency in your surf shorts or your bathing suit so it'll dry quicker? So those chemicals are put in, this better living through chemical. Let's just add chemicals. If they're harmful chemicals in the 6 classes, let's really ask these questions. And then if we want to say for alternative, let's invest in green chemistry. Green chemistry has been around for 20 years. I just spoke a couple weeks ago. The Guardian had a big green chemistry summit in New York, and everybody loves green chemistry, but nobody really invests in it. The tendency is if a chemical is regulated, go for the chemical cousin, because it's just a drop-in replacement, and that's what industry wants. So it's time in those classes, if it's necessary, to really invest. So we have a webinar series. They're 15-minute webinars on each of the 6 classes. You can go to 6classes.org and listen. We have some handouts in the back about the webinar series. Or maybe you could hold up one of the handouts just so people see there when you go out. Okay, so they're handouts if you would like to know more, or just go to 6classes.org. And if you wanted to now, you could pass out, if we send out monthly newsletters and updates on how this is going, so we have some flip charts. If you want to sign up, you'll hear from us once a month, only once a month, about progress. And when we did this webinar series, did anyone here listen to it? Okay, one person. So was it helpful to you?
It was.
So
we did a deep dive into kind of each section.
Yeah, but it's a sort of 20-minute deep dive. It's not too bad. So 1,200 people signed up from many of the major companies and retailers and manufacturers, and things happened like the next day after the talk on antimicrobials, Target called us and said, we had no idea we had these antimicrobials in our personal care line, and we're taking them out. They said, don't tell anyone because they're still in our stores, and a year later, Target announced it. But for us, it's like overnight, a company can say, I had no idea, and I'm changing my policy. So that's why I say purchasing is really important. Making purchasing choices is really, I think, the key. Because purchasers are faster and more powerful than government. Government really has issues in chemical regulation. So manufacturers of consumer products can say what goes into their products. Large retailers like Target can make better choices. Some of you are institutional, educational buyers. You can make choices. And I think all these sectors can be educated. Consumers are tough, because consumers are exposed to so many things and so many messages. It's hard. It's really hard. But all these purchasers, if they learn about harm, can make better choices. So a very exciting thing that's happening out in California where I live is the Buyers Club. And this is all these major companies like Kaiser and Google and Facebook have come together to use their collective purchasing power, which is tens of billions of dollars, and say, we want to know what's in our products. There's a big transparency problem where it's very hard to learn what is in many products. But we want to purchase from people who tell us what's in the products. We demand transparency, and we want to use our collective purchasing power to create a demand for healthy products and materials. And in this case, it started, Kaiser said, we're not going to buy furniture with flame retardants for our hospitals and our offices. And then all the other companies said, how did you do it? And Kaiser told them how, because it's never easy to make changes like that. And then all these companies said, we want healthy workplaces for our workers and our patients, in the case of the hospitals, and we're going to do the same thing. So buyers clubs are really powerful, and there's lots of opportunities. We actually have a project on healthier environments in affordable housing. And there's a housing partnership network of the leading housing and community development nonprofits, and they're now talking about using their collective purchasing power so that people in affordable housing can have healthier environments. So there could be the Dean of Arts and Sciences at Oberlin called me and said, we're thinking of getting the colleges in the Midwest. We all have a group to all come together and share best practices for healthier products. So that's something that can be done, and the power of collective purchasing can really start to move the market. So going back to the 6 classes, we're now going to talk about the highly fluorinated chemicals, the Scotchgards, and these are my new favorites. They are the worst of the worst because they don't ever break down. And that's because the carbon-fluorine bond is the strongest bond in the periodic table. So that leads to the good qualities. There's this extreme oil and water repellency, but it also means they last for geologic time. Nothing breaks them down. So you make this molecule, you want a Teflon fry pan, so it's made with a fluorinated chemical. Those chemicals will be around 1 million years from now. And they stay on the planet, like the planet is filling with these kinds of very persistent chemicals. So it's a very serious decision to make a chemical that never breaks down. PFOA, which is 8 carbons with fluorines all around. PFOA is the one that's very well known. There's a book, Stain-Resistant, Nonstick, Waterproof, and Lethal, The Hidden Dangers of C8. And this is actually about what's happening today. Today is the first trial where DuPont had a Teflon production plant and C8 got leaked into the water supply of several 100,000 people in southern Ohio and West Virginia. And DuPont lost the lawsuit and had to measure the levels. All these people had very high levels, and they did epidemiology and found that they had a series of health problems. Let me just go to that. So they found 2 kinds of cancer, elevated cholesterol, thyroid disease, all these conditions. Tens of thousands of people are suing DuPont. The first trial's today, and I just read that DuPont said, well, yes, our toxicologists since the 50s had said there appeared to be harm in animal tests, but if it had really been harmful, wouldn't the government have regulated it? That was their defense so far. This was from a local paper. I don't know if the New York Times is going to cover these trials or not, but it's going to be interesting. So where is C8 been found? Food contact papers, anything that keeps oil and grease is likely to be treated with one of these chemicals. So pizza boxes, microwave popcorn bags. We did a study of food contact papers around the Bay Area and discovered some of the organic restaurants were using paper with fluorochemicals because they had no idea. It's in a variety of cosmetics, but not that many, so it doesn't have to be in cosmetics. One easy way to reduce your exposure is to look on your cosmetics, and it will say fluoro, F-L-U-R-O, and that will mean it's in those cosmetics. Lots of outdoor gear, as I said, carpets, fabric treatments, clothing. So those are the places, and when it's stain repellent, water repellent, it may well have these chemicals. And in terms of, I guess I heard there are a lot of furniture purchasers. You should consider getting your furniture. I mean, if you're a furniture, well, I shouldn't ask, but I assume that many of you, when you purchase your furniture, you just get the stain repellent treatment because it sounds like a good idea. And it sounds like it'll make it last longer. But then you might ask, is it worth it when you know that that stain repellent treatment is a chemical that will never break down, that's harmful? And it's really great news. And again, I can't say who yet, but one of the major furniture retailer manufacturers in the U.S. is no longer offering stain repellent treatment. So if you go into that store and they say, we're not offering stain repellent treatment, you'll know why. And they did it. They said, it's a profit center for us, but we're not going to offer it anymore because we know how harmful it is. And we're hoping that this will set a model for all the furniture companies to just not offer stain repellent treatment, or to make sure that there is a really great alternative. So C8 has been phased out. It was in the 60s when DuPont started, their scientists showed how harmful it was, but they phased it out in 2015, and they've replaced C8 with C6. 6 carbons with fluorine around, 40 kinds of it. It's also persistent. It's in groundwater, wastewater, and seawater. They're increasing levels in human blood. It seems to be harmful to human health. And I just heard from Philip Grandishin, who's a wonderful scientist here at Harvard who studies them, that it tends to lodge in our brains, C6, just what we want. And there are 40 kinds of C6, different structures. Are we ever going to, and DuPont says, they say, well, C6 is better than C8. Well, better than what? And are we ever going to know about all 40 forms of C6? Are we ever going to have data? So we have to say this is a class of chemicals that we really don't want to use unless we really, really need it. Do we really need that stain and water repellency enough to use C6? And another great example, IKEA, about a year ago said we're not having any fluorinated chemicals in any of our products worldwide. And they said they did find replacements for shower curtains, raincoats, umbrellas for water repellency. And interestingly enough, their replacements were made by DuPont, who claimed there were no replacements. You know, when IKEA said we're not buying any more fluorinated chemicals, suddenly a replacement showed up. But they don't yet have a good replacement for oil and grease repellency. So IKEA said we have this nice tablecloth that really sells well, but it requires oil and grease repellency. We've given the chemical industry 6 more months, but if they can't come up with a substitute, we're not going to sell our tablecloth anymore. And that is a really principled stand, and that's a stand that we are hoping many American companies will also follow. We think we helped move this along. As scientists, we put together the Madrid Statement on Highly Fluorinated Chemicals. That was last May. It was published in Environmental Health Perspectives. It listed all the potential for harm and how to prevent further harm. It was signed by 230 scientists from 40 countries, and it got quite a lot of press. Fluorinated chemicals have not gotten the press they deserve, but it did, and Nick Kristof wrote about chemicals in your popcorn. National Geographic, these chemicals in pizza boxes and carpeting last forever. My favorite, Modern Farmer, massive group of scientists think you shouldn't use nonstick. But the word is starting to get out, and very optimistic. All these companies, these brands, have pledged to eliminate all fluorinated chemicals from their products. And so I think H&M was the first. Levi's has actually done it. And I go hiking, you know, I'm a hiker, so hiking's my way of doing work whenever possible. I go hiking with the vice president for environment for Levi's, and I'm like, you've done this great thing, why don't you tell the world? And he's like, well, the brands don't really want the world to know yet, because what does that say about their old Levi's? So it's a problem that companies do this, but they don't necessarily tell the world. But this is in the public domain. So all these companies have made these commitments. And so remember when I've said we could have a 50% reduction of this? We're not saying 100%. If you really need it, I have to say that they're used in ski wax. And a few times a winter when it's really sticky and I don't get that many chances to ski and I want a really good ski, I ski some fluorinated ski wax on my skis. And I know that it's going to be in my body for the rest of my life, but I really want that good day of skiing. And I'm doing it from an educated place. So I think if you're trying to ban things, it's harder. But if you say, let's only use it when we really need it, not just routinely put it in all our products, we can really have healthier products and be healthier. If people who are making buildings, the Buyers Club can go to a database called Pharos, and it lists the names of products with and without fluorinated chemicals. So you can consciously, if a company says we're not going to buy fluorinated chemicals anymore, they can go to this database and they can look for the products with and without the fluorinated chemicals, and then they can choose the ones without. And this, if enough purchasers, enough big companies make a commitment, that can help move the market. So right now, often the ones without cost more, even though they should cost less, because fluorochemicals aren't cheap. But if the market is all the ones with the fluorinated chemicals, you have to pay a premium not to have them. But if the buyers clubs all say we want them without, that can move the market. So, which is more logical, that the ones without the toxic chemicals will cost less in dollars, and they certainly cost less in terms of health harm, and for these chemicals in terms of the planet, because we really don't want the world filling up with chemicals that are toxic that never break down. In terms of consumer products, these are the sorts of products that would have fluorinated chemicals. So if it says it's stain repellent, water repellent, that's why the title of that book, Stain Repellent, Water Repellent, and Lethal. I mean, goodness. You can just think, do I really need it? I mean, in your swimwear, in your footwear, in your jeans, maybe in your jacket, but maybe not, you know, to make those choices. So this talk will, I think you're filming it. It'll be on our website. Yeah, if you go to greensciencepolicy.org, look under past events, and many talks that we've given along these lines are there. Okay, chlorinated antimicrobials, triclosan and triclocarban. They're used in liquid soaps, in toothpaste, Colgate Total, 0.5% triclosan. And I've heard happily that Crest is now advertising they don't use triclosan, and this is great because people are starting to realize you don't need triclosan in your toothpaste. My friend who researches them said, if you have gum disease, it might be worth it to have triclosan. It kills all the bacteria, but children shouldn't have it. Liquid soaps, it's good to have bacteria on your hand. It's really healthy, bacteria protective. Soap and water is by far the best way to wash your hands, not with these molecules. And then when you look at the structure, it's those two phenyl rings. It looks like a lot. That kind of structure really is a problem. You remember that flame retardant? It looks a lot like the flame retardant. So as far back as 1974, the FDA wrote a monograph on the lack of efficacy and safety of triclosan in soaps. And that report has never been published. And that's the sad thing, that the government is so hard for them to do anything. Meanwhile, in 1994, it was considered a drug, and there were only a few dozen uses. Now there are 2,000 antimicrobial products. So it's an added value. It goes into everything, you know, countertops, walls, ceilings, doorknobs. It sounds like a good thing for everything not to have bacteria, but it's not a good thing. Not a good thing for the health of those who are exposed, and it's not taken out in sewage treatment plants, so it's one of our top 10 water contaminants. It's in fish, and it's in most American women's breast milk. It's an endocrine disruptor. We do not want triclosan in our breast milk, but it ends up, when it's in our products, it enters the water supply. As I said, there are 2,000 antimicrobials. Here we are, the 40th anniversary of the FDA monograph, and nothing has happened. So, but remember, Target took it out overnight. That's what purchasers can do. And again, with products, there are kinds with and without antimicrobials in this Pharos project. So people can consciously, and there are more than this number, consciously move towards products without antimicrobials. And the list in consumer products, we won't go through them all, but you know, soap, shampoo, deodorant, toothpaste, because it's considered a pesticide, triclosan is also listed as a pesticide, it has to be listed on products. So you can, when you buy these kinds of things, if it has triclosan in it, it will say it has triclosan in it. So triclosan and fluoro, those are two things you can look for on labels and avoid them. So now we're going to do our favorite, right? Flame retardant. Well, I can't tell. They're all favorites. You don't want to pick too many favorites. So we have flame retardants in many products because in the 70s it sounded like a good idea. And they got added to children's sleepwear, furniture, foam plastic building insulation. And nobody said, is there a fire safety benefit? And the answer is not really, usually. And is there harm? And the answer is often great harm from the flame retardants used to meet the standards. So for flame retardants, it's not as much about purchasing, it's about changing standards. Because if you have a government standard that you have to have flame retardants, you have no choice. But then once standards change, you do have a choice. So my involvement with flame retardants started a long time ago. I'm a mountain climber. A friend who was an early environmentalist tragically died in the Himalayas. I wanted to do something in his memory and heard that there was a flame retardant. It was 10% of the weight of the sleepwear that most American kids were wearing. And there was a worry that the flame retardant might be migrating into the children and might be harmful. And you remember foods, drugs, and pesticides that go into our mouths directly are regulated, but other chemicals really aren't. So we found a little girl whose mom had bought her jammies in the UK because she didn't want her to wear flame-retarded pajamas. And so we put the little girl in the flame-retarded pajamas. We collected her urine. The first morning, we found brominated tris flame-retardant breakdown products in her urine. She wore the pajamas for 3 days. The level went up. She stopped wearing the pajamas, the level went down. So the flame retardants, even though it's supposed to go into your mouth, somehow the flame retardants were getting into the little girl. And so we ran a test to see if this chemical was a mutagen. Did it change DNA? It was one of the strongest mutagens we'd ever seen. So being scientists, we wrote a paper for Science, a big lead article. And this is an unusual paper because the subtitle says the main flame retardant in children's pajamas is a mutagen and should not be used. Now, do scientific papers with, a postdoc doing 2 experiments usually end up making such strong recommendations? For those of you who do scientific papers or read them, they always have the same recommendation at the end. What's the recommendation? Further research is necessary. And at the Green Science Policy Institute, our goal is to really encourage the scientific community to go beyond further research is necessary to how can my research impact the public health, public policy, public good, and make recommendations. And that's a hard thing for scientists to do. They're not rewarded. It's not in their reward system, but it's necessary because the scientists are the people who really know the harm. And we have found actually with the fluorinated chemicals that we started having a call for scientists who studied them, and all the scientists are just piling on from all over the world with examples of the harm from fluorinated chemicals and then coming with ideas for reducing the harm. So scientists really understand the harm, they're studying the chemicals, and they can make recommendations, and scientists have a lot of credibility. So we wrote this paper a long time ago, January 1977, and then April 1977, a few months later, tris-treated children's garments were banned by the Consumer Product Safety Commission. And is this something people remember? Probably, no? Yes. Anyway, a lot of people do remember this. So brominated tris was banned, but once again, the replacement for brominated tris was chlorinated tris. Very similar, but understandable. Why change your process? Chlorinated tris looked like a worry. We ran more tests. It also changed DNA. We wrote another article in Science. It was removed from kids' pajamas in 1978. But what we didn't know is that chlorinated tris continued to be used in furniture. And indeed, in 2005, an extremely harmful chemical was stopped being made for use in furniture, and the replacement was chlorinated tris. So does anyone have a couch that they bought between 2005 and 2012? Anyone here? Okay, so your couch has about a 2/3 chance that the foam is 5% by weight chlorinated tris, the same chlorinated tris. So if you have 20 pounds of foam in your couch, you have you have a pound of chlorinated tris in your house. And if it isn't chlorinated tris, it's a chemical called Firemaster that might be worse. So why is this? And this is because of Technical Bulletin 117. And I bet many of you who are involved with furniture have heard of Technical Bulletin 117. It requires, it's a California rule, but it is followed across pretty much all of North America because it was the only rule and everybody followed it. And it required the foam inside of furniture to withstand a very small open flame for 12 seconds. And that's Sounds like a plausible thing. So if you have a piece of foam with and without flame retardants, the one with the flame retardants will not burn for 12 seconds. It does what it says it will. People say flame retardants don't work. No, it works. It stops flame in bare foam for 12 seconds. But does it help in furniture? So if you do a little thought experiment, imagine a candle drops on your nice couch. What burns first? The fabric. And then do you have a teeny flame or a bigger flame? You have a bigger flame. And then the foam burns in maybe 1 or 2 seconds. And when foam is mixed with flame retardants, you get lots more soot, smoke, and toxic gases. And what kills people in fires? The soot, smoke, and toxic gases. So thanks to Technical Bulletin 117, since 1975 when it was implemented, virtually all the furniture in North America has been 5% a very harmful chemical. There's been no fire safety benefit, and pretty much all of us have that chemical in our bodies, and it's really not good for our health. So what is that chemical? My quick chemical lesson. So remember, this is a biphenyl, 2 phenols, lots of chlorines around it, polychlorinated biphenyl, PCB, cancer-causing persistent. If instead of having a covalent bond between your 2 phenyl rings, you have an oxygen, that's called an ether bond. And you put bromines around it, you have a polybrominated biphenyl ether, or a PBDE, right? Now you know what a PBDE is. You've probably heard it, and it always sounded like alphabet soup. Okay, polybrominated biphenyl ether. If you take your PBDE and you burn it, add oxygen, another ether bond, you end up with this molecule, which is a dioxin, or a furan. You know those molecules? Cancer-causing, persistent, harmful. So the PBDE is halfway between a PCB and a dioxin. And this PBDE with 5 bromines, it's called penta-BDE. That was used almost exclusively in our furniture from 1975 to 2004. So anyone who has a couch from before 2004 or earlier, it's very likely that you have a pound or 2 of this in your couch. Does this sound smart to put a chemical like this in all consumers' homes? We had students at Berkeley doing a course on chemistry and policy, and I inquired, is it okay for them to, collect foam samples? And they said, well, only in a fume hood wearing full protective gear. But wait, that's in everybody's couch. So this chemical, 98% of the use was in the US to meet our flammability standards, and yet it's become a global pollutant through the whole planet. And the reason is that the chemical is called semi-volatile. It's always coming out of products. So you don't get exposed because you sit on your couch. You get exposed because the chemical comes out. It drops into dust. You get dust on your hands. And the dust on your hands, you eat a sandwich, it ends up inside you. Sadly, toddlers tend to have 3 to 5 times the level of their parents. Why would that be? They crawl in the dust, they put their hands in their mouths. Cats have 10 to 100 times higher levels because of, they lick their fur. So what are the health problems with penta? Well, in animal studies, there's literally thousands of papers showing reproductive and neurological impairments and cancer. There are now a number of human studies. You really don't like having enough exposure to have human studies, but you find with when pregnant women have higher levels of penta, it takes longer to get pregnant. Thyroid hormones are altered during critical windows of brain development of the fetus, so their children will have lower birth weight, impaired attention, poor coordination, lowered IQ. I mean, that doesn't mean every child has all these problems at all, but across the whole population, it was calculated the average California child has about 5 less IQ points. Somebody put, an economist, an $8 billion price on the loss of IQ of kids in California. So the price and that's just one of the problems. And in animal tests, it is cancer causing. So we're all, 97% of our population has penta in their bodies, trying to prevent, I think there were 30 preventable furniture fires a year in this country that were not prevented. So that's the balance. The fire people do not think about the impact of the chemicals. And because our government doesn't have the authority, it's really not regulated. This shows how they go from products to people. And let's see what just go on. So the chemicals, as I said, do not have a fire safety benefit. If a couch has TB117 foam, there's no real difference from non-TB117 foam. And I heard that from fire test people like at Herman Miller. We were just talking about Randy Rester said, we did the testing for years. We knew there was no benefit, but we had to do it. It was required. And so when we got all that information, I thought back to the days of the baby pajamas, and I thought, well, we'll just tell the government and it will change. So we made a bill, and the bill was supported by the furniture industry, fabric, foam, juvenile products industries. Firefighters supported it because they have high incidence of cancer that's related to dioxin exposure, and when these flame retardants burn, you get a lot more dioxins. So everyone supported it, but the bills never passed. We had 4 bills, and why couldn't they pass? The opposition to the bills was Californians for Fire Safety. This is part of a $6 million advertising campaign. Don't let Sacramento politicians ban the use of proven flame retardants. And who are Californians for Fire Safety? Albemarle, Chemtura, Israel Chemicals Limited. The 3 manufacturers of the flame retardants, they spent $23 million preventing these bills that would have led to increased fire safety without flame retardants, or at least give people the choice, do or you don't want to put flame retardants in. So this was all very discouraging. In fact, I used to say that in those days when I went to parties and people asked me, what do? I'd start telling them the whole story of the couches with the flame retardants that had no benefit, that were harming everybody. And after a while, they'd all say, I have to go now. And I'd see them talking to people on the other side of the room. And, I thought, I'm going to, spend my life being the person just going on and on about flame retardants. So we did a couple things. We did a San Antonio statement documenting all the harm. So the chemical industry couldn't get up, and as they usually did at hearings, and say it's bad, not sound science to say there's a problem with flame retardants. So it was signed by 200 scientists. It was published in Environmental Health Perspectives, but still not much happened. And then the Chicago Tribune, investigative journalists, 3 Pulitzer Prize winning reporters did this incredible series, Playing with Fire. If you want to see it, you can Google Playing with Fire. And a deceptive campaign by industry brought toxic flame retardants into our homes and our bodies, and the chemicals don't even work as promised. So that says it all. They were finalists for the Pulitzer. They won all these journalism awards. The stories are absolutely scandalous. Like there was a burn doctor in there who would always come and talk about these babies that had died, these harrowing deaths because there weren't flame retardants in their cribs. It turned out there was no baby. It was completely made up, and the burn doctor had been paid $240,000 for his testimony. So that was the kind of crazy stuff that was going on. They wrote 4 major front-page stories, as I said, full of scandal. If you like scandal, read Playing with Fire. Everyone likes scandal. And then everything changed. Instead of me being the person ranting about flame retardants, Dick Durbin started ranting about flame retardants. There were hearings in the Senate. Jerry Brown, our governor, got educated, and he directed our state agencies to change our standards, and they found a way to increase fire safety without these flame retardants by stopping the fire in the fabric. And we now have a new standard, TB117 2013, that was mandatory in January, requires products to be labeled either contains added flame retardants or contains no added flame retardants. So you can actually all go out and buy furniture without flame retardants. And the really good news is we hear from the foam industry that in the old days, all their foam had flame retardants. And if you wanted something without it, you had the special order. And so then all these products that wasn't required, like all the sleep mats in the nursery schools all had flame retardants. It's just like everything had flame retardants. But the foam industry really doesn't like flame retardants. They said making foam is like making a souffle, and flame retardants are a really bad ingredient. So most of the companies have said, we're not putting flame retardants in any of our foam. Automotive foam still requires it, and some of the companies are saying we're not going to make automotive foam anymore. So what it means is the foam supply isn't going to have flame retardants. I mean, here in Boston, and I don't think we'll have time to talk about it, but maybe in questions, there's a special problem in Boston that they have uniquely strict fire standards for public places. And we maybe can talk about that, but let's go on and just say building insulation. It's a similar issue. The foam plastic insulations that give us great energy efficiency are always treated with some of the most harmful flame retardants. And we have been working to change the international building codes so that at a place like, say, below the slab in the soil where there's no oxygen, no possibility of fire, flame retardants aren't needed, and there can be a choice about whether or not to use them. There's code hearings that happens only once every 3 years, just coming up in Long Beach. If anyone's interested, see us. It's a real problem because, once again, the producers of the chemicals, and in this case, the producers of the material, it's the same chemical industry, so this is a really hard thing to change. Okay, I'm going to quickly, and it's out of time, I'll just mention the other classes, bisphenols and phthalates. You've all heard bisphenol A is bad. You buy your water bottles that say bisphenol A free. But one of my scientist friends who studies this, who kind of likes to be a contrarian and get people's attention, says, I like to buy bottles that say they have bisphenol A in them because when they don't, they have bisphenol S, which is worse. And so often the replacement for bisphenol A is bisphenol S, which appears to be worse. And so with the class concept, we don't want bisphenol A to Z. We want to say, do we really need this? Maybe we need glass bottles or metal bottles, or maybe we need to really invest in green chemistry. Similarly with phthalates, certain ones are phased out, others are replaced. Best to move away from phthalates if you can. There are several classes of solvents that are harmful, and often you can use water instead, or if you really need the solvent, really reduce the amount you're using. Metals, we know they're harmful. They have to be removed from our products. So I think things are starting to happen. Many retailers are now only selling furniture without flame retardants. Home Depot, Lowe's, and Menards are phasing out all phthalates in floor covering, which is a good step forward. The star is IKEA. IKEA, as I told you, this year has banned all highly fluorinated chemicals from their products, but they have in the past banned from the other 6 classes, triclosan, flame retardants, bisphenols, phthalates, chlorinated solvents, lots of metals. So IKEA, and because they control their supply chain, they can do that. Target can only ban the Target line. Costco is interested in removing fluorinated chemicals from their microwave popcorn, but they can't do the other brands. So the challenge that we see, and we're optimistic, is can the use of some, or maybe even all, of the 6 classes containing chemicals of concern reduced by 50% in 5 years? And I'm really optimistic, particularly with flame retardants. This is in consumer products, so we're not going to work on industrial products. But I think this can happen in furniture, in clothing, in things that really impact consumers. And I think that can make us all healthier. So I think, though, it's a little depressing to hear about those toxic chemicals that aren't controlled. We as purchasers, small and large, can make a difference. And I think many of you have signed up now for our e-newsletter list, so you'll hear from me once a month. Give me your card if you want to and you didn't sign up. So I'm just going to end by saying I feel very optimistic that we can make choices, reduce the use of whole classes, and have a much healthier world. Thank you.